Okay, so welcome aboard, everyone. We are getting down there. It seems like we just started, and here we are on lesson 4 already, or session 4. So we have one more to go in April. I believe it's late April that we'll be going. And then that'll just be for May and June to kind of wrap up the year and see where we're at that point and how things are going. There's been a couple of requests that came in as well for people asking for a couple of things. So I've embedded those into the end of the slide deck. Just if you're wondering why all of a sudden did those come in here, that's why they're there. And we'll go through them. I've also embedded slide decks within this slide deck, so you'll have to be a little bit patient and do a clicking depending on where you're at and what it is that you're needing for some of your resources at this point in time. Okay, so let's get going. We'll begin with our land acknowledgement, and in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. And I'm coming to you from Treaty 6 in Camrose. That's where I have my home office. And in the bottom, you have a link here. Wherever possible, try and put some things in that link to what it is that we're about to do. And in this case, I've given you a link that deals specifically with mathematics and looking at mathematics through an Indigenous lens. So there's some resources in behind that link, so I won't go into it now, but I'll just leave that to you to peruse and go through at some point in time. So what we're going to do today, kind of in a big way, because this is pretty much where everybody's at or finishing up, or we're into fractions all across the province at just about every grade. Fractions are at that time, and hopefully you've had some time to go back, fill a little bit of the information that the students wouldn't have come to your grade with. Given that you're grade 6, they won't have done a good portion of the fractions that now are being done in the new curriculum. So there is always that need to make sure, first of all, that they have the understanding of what they should have had from 4-5. And I built some of those pieces into this slide deck for you today. Again, you will just need to go into those slides and say, no, we got this part. I need to fast forward through. And that's fine. That's the whole idea, is that you don't have to recreate the wheel. There's materials there if you need them to go back to, and if you don't, or maybe just use them for review at the end of the year. That's the other way that you could look at them. So we're going to look at the fractions, specifically looking at quotients, because this is really where that comes to play. And the kind of the stumbling blocks that we came into in grade 4, where you were asked to do hundredths and tenths, that they weren't in a position to take a fraction and find a quotient because they didn't have that in their curriculum. So we had to find other ways to come up with those tenths and hundredths that legitimizes what the students understood, but without doing it as a numerator divided by denominator, because that's not in their curriculum. Adding and subtracting fractions with unlike denominators. So in a perfect world, they came to you fully versed with adding and subtracting fractions with like denominators from grade 5. So we will do a little bit of work going back on that today. But if you really need to go back, I would say go back and pick up the resources and the slide deck from yesterday's session that we did with grade 5, because that's what we focused on there. And again, I built in some virtual slides that you can go into, and we're going to do some of that today. So I want you to be ready to do some things that I throw into the chat box, the links that we throw in there, because I want you to do it with me as we go along so they get a sense of how that works. You won't get through it all, but at least to get a start to it. We'll look at multiplying a fraction by a natural number, and that we're just going to really start on that. I'm coming back to that one in April, because if you've got everything kind of ready to go at that point in April, then you will be able to sail with me into that kind of multiplication. I've given you enough to start with in that, but maybe not so much that we're going to really unpack a ton of it. We'll look at expressions, solving algebraic expressions. They've been doing numerical ones. Again, in a perfect world, they came to you in from grade 5 with all of the terminology from algebra. You don't have that because they didn't do that, so you're going to have to backfill that. That's one you can't get away from. You must go back to grade 5 and do that. And just an FYI, There are no variables in grade 3 and in grade 4. They're open boxes, bags, squares, hearts, stars, they're symbolic placeholders, but they're not variables. We're not using M's and T's and X's. That does not come in until grade 5. So try not to rush some of that prior to that. The actual equations, like the big left side equals right side with a balance scale and using algebra tiles, we're going to get you up to that, and that's what we're going to unpack when you come back to me in April. So everyone's going to do equations in April in a big way. So if we can get them to understand what we want up until that point, if they've never done integers, they're going to have integers done before you launch into that solving equations. Otherwise, that's not going to make sense to them. And we'll do that together. That will be the majority of what we're going to do in that session is unpack that. So you're going to, again, be doing it live with me on screen. And then there was a request for, could I just show again some of the work, some links that we have, some resources for adding and subtracting of decimal numbers and large numbers. Since we have these big numbers that the students are supposed to tackle and get to, teachers are saying, well, I don't have any resources that go to 10 million. So I'm going to share a site that you can go to that we can do some work with the students and kind of get all of our outcomes done at the same time. So we're looking at February, March intently. We're looking at April in some respects finishing, and in other respects, we'll get you to a certain point. And then I want you to kind of join me in April to really hunker down on just a few selected topics rather than a whole bunch, so we can really get that solving equations down pat. So we're going to look at the 6 and 5, which talks about relating fractions to quotients. So that's where we're going to start. Then we'll have a look at adding and subtracting with unlike denominators, but we'll revert first to what does it visually look like to add a like denominator? And then what does it visually or model? What does the model look like to add an unlike denominator? This is not about telling me I can multiply the two numbers together in a denominator and get the common denominator. That's all true, but that's just process. That's just doing, but that's not understanding the why of how you're getting to that. So we need to not do that so quickly and just make sure the students can model the understanding before you just get me to do the paper and pencil. We're going to look at that multiplication of a natural number by a fraction. So this is another piece that we want them to get to, and we'll unpack this a little bit more when we do some of the solving of equations. But I think what we really want them to understand is how to model, first of all, how to multiply a whole number by a fraction. And secondly, we want them to understand that just because you're multiplying doesn't mean the number gets bigger. That's a misnomer or misconception students have, is they think that whenever you multiply something, it must get bigger. But if I multiply something by half, it's not going to get bigger, it's going to get smaller. So we need to let them see how that would work so that they actually understand what they're doing. And then again, we're going to talk about rates and ratios. If they've nailed everything up to 6 and 7 by the time we meet in April, then we can do rates and ratios fairly quickly, because that's really the same language of fractions. It's just changing the terminology because the units that we're going to compare will be a little bit different. So we will look at algebraic expressions as well, and we'll back up a little bit into grade 5 so that you have that background. One of the questions that I was asked recently was, Chris, you keep saying unit fractions, and so just curious where that's coming from. So these are just cut and paste directly from your curriculum documents. And I didn't really go through everything and highlight them all, but this is the development of a unit fraction actually starts. They don't use that term unit fraction, but it comes to that sharing idea in kindergarten. In grade 1, we look at 1/2 as a word, but that's a unit fraction. And then by the time they get to grade 2, they're talking quarters to start with, and then they get into unit fractions of a denominator no larger than 10. So it starts right there. And that's where that unit fraction is the foundation to everything they do. It's not just because I can see that money helps the student understand that. The money actually connects the unit fraction idea all the way through for children. So it's the foundation. And students need to know what a unit fraction really comes out to be. And why is it so important? So this is how it just, and I won't go through them all, but you can kind of see how that development goes and goes through. And then as we get into grade 5 and 6, we see again that fractions with common denominators are simply multiples of the same unit fraction. So it keeps coming back again. It's not something that we can just say one and done. I taught you what it is. It's a number with a 1 on top. It's bigger than that. It's much bigger than that. So we can't kind of walk away from fractions and say, I did the unit. I did the unit on fractions, we're done. It just keeps coming back. So we keep coming back to it as well. Okay, so let's start with 6 and 5, which talks about relating fractions to quotients. So I've just underlined a couple or highlighted a couple of things from our document that's already there, where we talk about an equal sharing and that division is used to determine an equal share. So a fraction represents an equal share. And we say that the denominator says how many equal share parts there are, and the numerator is how many I get to keep. That's what I'm getting. So if I get 2/3, I'm getting 2 of the 3 equal shares. That's really what it's coming down to. Some people would say those equal shares are the number of parts that something has been divided into, but we just need to remember, if we're going to talk that way, they're equal parts that we've divided into, not just parts, any old part. So just as an example, you see on the bottom, I see equal shares in each of these examples that are shown here. I also see the same shapes cut into the same number of pieces on the right-hand side, but they are not representing equal shares. So they would not represent 2/3. If I was talking about parts of a whole and not necessarily reflective of equal parts, then the ones on the right-hand side could be talked about differently, but that's not what we're referring to, okay? So that's an important part. The other piece is that when you look at the skills, they're saying, first of all, can they model? Well, could you give them a piece of paper and say, could you divide your paper into 4 equal pieces? You know, can they fold it so that it's 4 equal pieces? There's more than one way to do it, but could they do that? Can they describe the equal sharing situation? Can they come up with an everyday scenario where they might be trying to share out something that's equal to 3 or 4 people or 5 people? Express a fraction of that sharing. Each one of us gets 2/8 or whatever it is. And then convert a quotient from a fraction to a decimal. So this is where now we can show them that when we take a numerator divided by a denominator, I can get a decimal. But again, if that's all we tell them is top number divided by bottom number, that's procedure, and that's correct procedure. But that doesn't mean that they understand exactly what they just found. It means that they can probably just figure it out, write it down, but that doesn't mean they understand it. So that goes back to the money thing. Again, if I can change it to money for them, now it makes sense to see why that decimal is there. So in grade 6, where they're asked to put numbers on a pad, for example, put numbers on a number line, a lot of our kids would struggle putting 1.26. Where would you put that on a number line? And strangely enough, though, if you say $1.26, oh, well, they have no problem putting it in there. So put a context around it, and maybe they won't struggle quite as much. The other piece is that we need to make sure that students understand what that bar is in a fraction. Like, that's not necessarily, even teaching 18-year-olds, I can tell you that a lot of them wouldn't even have a clue. They know it's a fraction, but as far as paying attention to that bar actually has a meaning, that's not necessarily common knowledge. So that bar not only separates the numerator from the denominator, but the bar actually shows the equal division in 5 equal parts, and I get one of them. It's a division sign. That's really what it is. So that's what facilitates us being able to say that I can take a fraction and use that to change to a decimal, because if this represents a division sign, then really I could have written this as 1 divided by 5, and I can. That's exactly what I'm going to do. So that's how I convert a fraction to a decimal, and legitimately so, because of what each of those components represents. So again, I could give them I've got $1 and I want to divide it between five people. How much is everyone going to get? Well, I can just go 1 divided by 5 and get decimal 0.2. I can get that. But if I put the context of $1, 0.2 is the same as 0.20, 20 cents. If I understand money, it's 20 cents. That makes more sense to a lot of our kids than just 0.2. That's procedure. understanding and context becomes the most important part. So when we do, and I'm not going to go back over these, but we've been doing these pictures for a while where we showed what the grade 3s were doing, putting dimes on a number line. So now I can legitimately say, if they can't figure out what 1/10 is as a decimal number, which they should have from grade 4 in the new grade 4 curriculum, I could go 1 divided by 10, right? So I can give them some tools that they can go through. So here's where we did the pennies on top, we did the nickels in the second row, we did the dimes in the third row, we did the quarters in the fourth row. So I can legitimately change some of those to money values, dollar and cent values, just by doing a division. Hopefully they've already done that. So just as a quick review, again, if you haven't done a lot of work with money, giving that context to students helps understand fractions and decimals right away. But in grade 4 and in grade 5, we weren't allowed to go a numerator divided by a denominator. So how do you transition then from a fraction of 1/10 to an actual decimal? So all of those students since grade 2 have been working with this template, and we've never put a decimal there. We've just put a black line saying, here's what divides dollars and cents. That's all we've done. I don't need to know about decimals to know dollars and cents. I just need to know that if I finally get 100 cents over on the right-hand side, I get to trade it for something called dollars on the other side. So really, this was just a dividing line is all it was. In actual fact, it's the decimal. That's the same thing. So when we want to change 10 cents and reflect it as decimal 1, I could just say that to kids. I could just say, grade 4s, did you know that a dime is the same thing as 0.1? Factually true. But how are they going to figure that out when they're on their own and they get stuck? So what we do at this point is say, if you had 1 dime, where would you put that? Well, I'd put 1 dime over here into my template. If I have 1 dime, I had no pennies. So that would be 1 0. And since that line represented the decimal, you now can start to see that a dime became decimal 1 0. Leave the 0 in, doesn't matter. What would 2 dimes be? Well, it would be 2 dimes, no pennies. So decimal 2, decimal 3 for 3 dimes, and so on. So they realize that incrementing by a dime is incrementing by a decimal 1 each time. So that's how we transitioned grade 4s who can't do what the grade 6s can do into understanding how they get tenths. And now let's do pennies. If I say put a penny into the template, where will you put it? Well, you're going to put 1 penny right here. Well, how many dimes did you have? I had no dimes. So 0 dimes, 1 penny. So that means that a penny is decimal 0.1. And we can talk about place values and all those things, but really we have to give them a context. You can just say it's decimal 0.1, but that doesn't give me an understanding of how to bail myself out if I don't understand how to get there on my own. So 2 cents would be 2 pennies here. How many dimes did you have? 0. So decimal 0.2. How many would 5 cents be? Decimal 0.5, and so on. So they realize that for every penny, they increment by decimal 0.1. So there's my hundredths place value that we were talking about. This is another template that you've seen before, but would definitely help transition a grade 6 student who might get stuck along the way, hasn't been working a lot with decimals or fractions. It kind of gives them both. So here I have the dollar values. Again, if you wanted to put a big dot here, we could, and say a dime, how many dimes do I have? And this is how I would transition or multiply to figure out the dollar values. Here's what it would be as a unit fraction, and then the total amount. So again, it gives students that opportunity to transition from one to the other. You can find this placemat at the hyperlink that's right here. It takes you to the ARPDC site where we put all of these money placemats. And if you select the one, when you download it, it'll come as a zip file. Just pick the one called place value. And this is what you'll get. There's a whole bunch there, but this is the one that really links well for grade 6s. So as we've also been saying, you are trading for a unit fraction and converting. You are trading base 10 blocks initially for money. That's really what you're doing. You're not saying throw them away. We're not saying pack them in a cupboard and never use them again. We're just saying, let me understand first what you want me to do and let me get a context for it. And then if you want to bring out the base 10 blocks again later, you can. But remember that in a base 10 block, I have to switch the rules, right? I don't have tenths and hundredths. without saying, oh, by the way, I need to rename this flat and call it a 1. This becomes your tenths, this becomes your hundredths. I don't have to do that when I have money. I've got them all. I've got everything there. I don't have to give you a new rule. So there is the advantage to having the money over the base 10 blocks when we get to decimals, okay, not for the other one. So when we talk about fractions, we're talking about being less about prescriptive, here's the terminology, just label it and learn it, versus trying to understand the why behind what it is that we're going to ask you to do. Okay, so that's kind of the division piece, and that part isn't that difficult because the kids can divide. That's never been so much of an issue. They're not dividing anything larger than a denominator of 100, okay, so they don't go over that. So you're not going to give them odd numbers either. Like you're not going to give them denominators of 11 or 17 or 19. Not that you couldn't, but I guess I would always go back to say, is it real? And how many places in your lifetime have you divided something in 11 or 17 or 19 pieces? You don't. So pick things that would be things that I might see in a day-to-day routine or on a ruler or things like that. So if we combine some of this understanding now with the fractions, we understand a little bit about I can change from fraction to a decimal. Let's keep moving with our fractions. And let's talk about how we're going to add or subtract fractions that do not have the same denominator. And you can't do that until I have understood or you've taken me and done the grade 5 with like denominators first, right? You can't just come in with the rule and say, take 2 and 3 on the bottom, multiply them, get 6, and then change it. No, they need to understand how they got there. And they also need to understand that those are equivalent fractions that we're building. So if we haven't done equivalent fractions a lot with them, we need to do that first. We need to do adding with like denominators first. And that will give me the why about how I'm going to get to the process that you're going to show me to do unlike denominators. So it is a bit of a scaffold here, and you really you can't skip a step here. It's not going to work. So the product of denominators of two fractions gives me the common denominator. It's written right there. Yeah, that's the rule. But if you just give me the rule, then I'm going to be the kid who memorizes the rule. And then in grade 8, when you ask me something really complicated like a fraction and a decimal, and you want me to convert both of them into one format, I'm probably going to look at you and say, huh, I don't understand what you're asking me. So if we give them the why now, it should make it easier later on. Recognizing two fractions are related in denominators. That's the other piece about how do I convert from unlike denominators to the same denominator. So that's really what that is talking about. Determine the factor that relates one denominator to another. So again, in grade 4, they did finding composite and prime numbers. They did factors of numbers. So this goes directly back to grade 4, finding factors of numbers. If I don't think they're strong in that, I do need to spend some time there. You can go slow here because the more you get that behind you, the faster you will sail through fractions. If they get those little pieces together, then the fraction doesn't matter, like denominator or unlike, isn't going to take you long to cover because they'll have the why behind it already. So there are some things that we want to redo or review from grade 5. And in the slide decks that I'll show you in just a second, I did take you back to grade 4, then to grade 5, then to grade 6. So you can leap in wherever you think you're ready, your kids are ready to go. All right, so we did this sheet. We've seen this one many, many times before, where we ask them to label and count by unit fractions. This is getting to that whole addition and subtraction of same denominator, unlike denominators. So could they add? Could they count by unit fractions? That's one of the goals that they have in grade 3 and in grade 4. If they can count by unit fractions, then I can also see how I will get into improper fractions. So this is the picture of grade 4. Grade 5 goes into, let's not have 1 at the end. It can move around. So that'll allow me to get improper fractions. They don't have that in grade 4. That starts in grade 5. So now I can have improper fractions that all still have the same denominator that I could add together and that I could simplify into mixed fractions and decimals and percents. That's all grade 5, right? So I'm unpacking all of those pieces that already tied into fractions as we go along. So this is, and again, I'm not going through the whole thing, but this is one of the slides that we unpacked with the grade 5s and even with the grade 4s about how are these all connected. So again, if you need some of that, go back and grab some of the slides from the other groups, because this will give you that connection that you need for there. So now I can see how a percentage is the same as a number out of 100 is the same as an equivalent fraction, which is also the same as the decimal. They should be able to see how these are all connected, not just, I'm going to do a shading of 100 squares today. Tomorrow we're going to talk about percentages. The next day we're going to talk about decimals. Do them all at the same time, so I start to see the connections between them. Okay, so when we move into the 6 and 7, that's the multiplying one. I'm not going to spend a ton of time when we get into the slide deck here right away. But what I want to just remind people of is that you're only doing a natural number times a fraction. You're not doing a negative fraction. You're not doing a negative number times a fraction. It's all positive natural numbers times a fraction. And just so that we're really clear that when you have that number in front of a fraction, you are multiplying the number times the numerator. So that's why we have AB. The denominator is unaffected by it, because this is like saying you have 7 groups of 3 halves. So the halves don't change. The number of groupings of halves that you have will change. So you're only multiplying the top number, not both numbers together. Okay. And so what they ask you to prove with the students is that you can, in fact, use the same rules that you had for number systems should work the same for fractions. The only difference is that, as I was saying at the beginning, we were just chatting, that some students believe that every time you multiply something, it gets bigger. So we have to show them how sometimes when you multiply, it doesn't get bigger. Like if I go 7 times a half, I'm not getting a bigger number, I'm actually getting a smaller number. So they need to understand that multiplication does not always result in a larger value. And we can come back to that again. Okay, so this is a card game. And I won't go into this card game. The whole card game is in here. But this card game is based on drawing a whole number and multiplying it by a fraction. And if you get a whole number back, so let's say it was 2 times 1/2. 2 times 1/2 would be 2 over 2 or 1. If I can get a whole number when I multiply the 2 cards I draw, I get to keep the cards as like point for me. So that's what this is about. And the kids like it, but it's a great way for them to practice. It's a wonderful way for them to practice. It can be set up as solitaire. It can be set up as games of 2. It can be set up in games of 4. It can be set up as memory. It could be set up as Go Fish. Like you could send it a lot of different ways. So the whole thing is there. The second one, though, is this fraction strips. Because before I'm going to go in and do all of this work here, go back to this sheet, this slide here. Or I go in and do some of the work that I see here in adding denominators, I don't want to show them numbers. I want them to be able to add and subtract denominators with just strips of color. If they understand unit fractions, then they'll be able to do that as quickly as you possibly could show me how to multiply numbers together. So in the fraction strips, I'm just going to grab them. I'm going to put this into the chat box. And if you can bring it up, save it to your computer, but bring it up on your screen as well. And we'll kind of go back and forth and play a little bit. Okay, it's in there now. You want to grab that one. Now, remember that fraction strips represent unit fractions, and that's really what it's showing you here. It's showing you that if the red is the whole, then this shows me I have 2 parts to that, and this is 1/2. The purples are a half. The next ones would be 1/3. But I don't want them labeled. I don't want to know what those numbers are. If the students know how to do unit fractions and understand them, that's a good test for the teachers to find out what they know. Then they get this. Then they can figure out that this is the thirds, this is the quarters, this is the fifths, just by counting. If they don't, then I'm going to say to you, I don't think they know what a unit fraction is yet. So that's where we stop. Just get that part sorted out. So this gives me the opportunity, just to give you a little bit of a sense too, you can adjust how many different rows you have. So on the right-hand side, you can play with that toggle a little bit. And you can see that I have up to, and this was his tenths that I have. If I want bigger numbers, and again, I'm not going to use crazy denominators, but if you want to change them, if you go into this little wheel that's in the right-hand corner, so if you come back to my screen, if you're on 1, you'll see that I've got these checked off already. That's what you're seeing. But if I wanted, let's say, 12ths, and I wanted 15ths, and I want 16ths, that's a common one for imperial. I don't know, 20s. If I click them on, I will get new rows added to the bottom. And to get back to your screen, just go to your X in the top right-hand corner. And then when you scroll down the side, you're going to see that you added a whole bunch of new rows to it. Okay, now in the interest of some time here, I'm going to grab mine that I had open. Oh. Okay, it obviously didn't save it, so I'll just go from there. So what I want to do is I want to be able to show students, let's assume that you know what a 1/3 plus 1/3 is. So if I say find 1/3, I can find it right here. I can see what 1/3 is. You have this little arm at the top here, this little upside down trapezoid, and it will show you the end of 1/3. So I can just drag it. So just grabbing it from the top left and dragging it over shows me where 1/3 is. But it also shows me that I have something else that's the same length as 1/3. There's 2 of these blue ones. Well, what are the blue ones? Well, they can count them. Those represent 6. So 2 6 are the same as 1/3. Okay, or at the bottom, I keep going and I see that I've got 3 down here. So now they're starting to see that I'm seeing equivalent fractions. This is what they should have learned when they did equivalent fractions, is seeing how those look, right? I see how those values come out to be. So let's just say that I want the red one to be a whole. You can grab it and pull it out. So if you want to grab your red one and pull it out, let's grab the purple one too while we're at it. And when I grab the purple one and pull it out, you'll see that there's these little boxes at the top here, and I've got one that shows duplicating. So when I click that one that has the 2 squares in it, I will get the full bar filled in. So let's pull the thirds out. Let's pull the fifths out. Like, let's just pull a whole bunch of them out. Oops, that's not what I wanted. Okay, I screwed up here. I'm going to get rid of mine and just start again. For some reason, my mouse is not cooperating. Now I can do some things within, what is going on here? Let me just grab a different one. For some reason, I've got something in there that I don't want. Okay. Now I'm going to bring some of these out because there's a little tool on the outside that's going to help me to be able to add unlike denominators together. And that's kind of where I'm going to skip to right now. We're going to assume that they know how to add like terminology together. So if I were to say find 1/4 and add another 1/4, what would you have? And then could you reduce it? That's the kind of question that they should be able to do already, since they've already been doing that kind of stuff in grade 5 and equivalent fractions from grade 4. Okay, so let's say that our question was find 1/2. If red is a whole, we're going to find 1/2. Down at the bottom in your gray toolbar that you have this little toggle. It looks like it has a pendulum hanging on it. If you bring that one up, or just click it on, it'll come up on your left-hand screen. And this is a nifty little tool because I can bring it and just pull it right over top of my fraction bar. And I'm going to find where 1/2 is. The purple is a half. And I'm just going to pull that down so that I can see all the places that the half lines up equally with other pieces that finish. So for example, the purple lines up with 2 yellows, 1/2, 2/4, same thing. I see that it lines up with 3 blues. Well, 1/2, 3 out of 6, same thing, right? So that's what you're finding. So that was my first part to the students, find 1/2. Now find 1/3. So I'm going to grab another pendulum tool and I'm going to find a third. In this case, that's the gold one. And I'm going to drag it over. And what I'm looking for is, where did the gold one and the purple one both cross the same color at the same time? So the purple met at yellow, it met at blue. This gold one doesn't meet at yellow, doesn't meet at green, oh, but it does meet at blue. They both have the blue in common. So purple plus gold equals a blue common denominator. That's where we start with the students. The common denominator is the common color. So when I start teaching in grade 7, for example, to find common denominators, I say to them, you're finding a common denominator is a common color. Find me the common color that they have. Which one is it? So purple and gold, what do they have? What's the first color they both hit at the same time? They hit a blue. You could try it with other ones, right? And just enlarge the length of the size of your value. So the 1/2 is how many blues? It was 3 out of 6 possible blues. The gold was 2 out of 6 possible blues. So I ended up with 3 plus 2, that's 5 blues, or 5 out of 6 possible blues. So just doing it with color first, finding color, color, color. What row are you in? I'm in the 6s row. They start to connect that 2 and 3 in the bottom, instead of me just saying to them, multiply 2 times 3. They start to figure that out on their own. And that's better than me just saying, here's the rule, just do it. Now I've got an idea of what it is I'm finding when you find a common denominator. It's a common color. If you do this with pattern blocks, you're going to do the same thing with a pattern block. You could give me a red hexagon, or sorry, a red trapezoid on top of a yellow hexagon. That's 1/2. You could give me a blue rhombus on top of a yellow hexagon. That's 1/3. I can't add a blue and a red together. They're not the same color, but what color do they both have in common? You could change them both to greens. You will get 5 out of 6 greens then. So again, it's common color determines how I find the common denominator. So this is a little bit of work that they should be doing. They should be doing this kind of thing. And actually don't ever bring paper and pencil in to teach how to find common denominators with junior high students until they can do this as quickly as I can call them out. And they just run their fingers down a sheet like this. They don't have to have necessarily a laptop in front of them. But this is engaging for them. It's easy to do. It's fun to do. There's a lot of little infos that you can do here. There's lots of little nuances that this program can do. We haven't got time to go through them all. All of these buttons offer you different things, like you can label the fractions on there if you want. But again, this is kind of like Cuisenaire rods. Don't number anything, just do the colors. And then if you want to get from colors to numbers, then go ahead and do that. But again, if I understand unit fractions, I shouldn't need you to tell me what they are. I should be able to tell you what they are, which one I'm counting by. So you have information sections right here, and that will give you extra sheets and ideas of what you can do with this. So that's one way that we would start before we get into the rule that says when I want to add unlike denominators, I can find the product of those two numbers, 2 and 3, gives me 6, and then I find an equivalent fraction by changing the denominators to 6. All true. So how do we change this a little bit to more of a scaffolded approach of learning? Down here, you also have in red, when it talks about adding and subtracting with unlike denominators, this is a slide deck that I would encourage you to have a look at. I wrote in the green at the top some things that these are, like what do these represent? So common misconceptions, just for us as the teacher. And most of us who've taught fractions would know that that happens all the time, is that students don't understand what that 2 and 8 is. That's because they've never seen it before in anything other than numbers. If I know that it means common color, then I already know that I can't go 2 plus 8. Like, they won't make that mistake if they understand the model. So these are common misconceptions that students will do when they add fractions. They just add the top numbers, add the bottom numbers, and that's my answer. And that's nothing new to anybody that's taught these before. Okay, same thing with 1/2 plus 3/8, same thing. I could just add them up and they know that, oh, wow, they should have been 8s, but I didn't change this to 8s, but I know that's going to be 8, so I'm just going to add the top numbers. That's a very common mistake for students to make. They know that they need to find a common denominator, but they don't actually do it. So that's the problem. So here's where we would start. If they aren't really good at it, fractions yet, you might want to start where it says grade 5 like denominators. So here's 3/8 plus 2/8 is my question. So I could show 3/8, and then to that I could add 2 more 8s, and the kids can just count them. How many do I have? Well, I have 5. Better yet, we did this a while back when those of you who were with me from K to 3, in grade 3, we say, cut those strips of paper, just take ordinary recycle paper, cut them in strips of paper and have them fold them into 8 pieces. And then they can do, where's 3/8 on your fold? Put your finger out at the end of 3/8. Put another 2 8s onto it. How many do you have? They can count them. They folded it. They've made the unit fraction. That's another way for them to embed it in their heads. So the total gives me a total of 5/8. Okay, if I was doing a subtraction, I start with the full amount first. So I show the 5/8. And from those 5/8, I want to take away 2 of them. So again, the denominator is the same. I'm working on the same strip. I end up with just 3/8 left over. So all of these slide decks in here start first with grade 5. And what are some prerequisites that they would have done then in grade 5 that would kind of lead into this? We did a ton of this work yesterday too, where we did the part whole. We did things about decimals. So how do you break up numbers so that they're still the same parts of the whole? This is all stuff that they would carry from grade 5. So again, this is why I included these, that if these are helpful, this is probably where we want to start first. Equivalent fractions, they know that this is 1/4. What would they look like if we said model it now for more than 1/4? What else would it look like? So if I'm going to do that, I could have 2 out of 8, I could have 3 out of 12, I could have 4 out of 16. Like, can they recognize all of those equivalent fractions in visual form, right? That's what we want them to be able to do. So could they see different representations of 1/4 or of 1/2 or whatever you're giving me? Okay, how does 1/2 equal 3/6? If you did the work with them in the colored templates, they got that. They understand how 1/2 could be 3/6. This is the purple, here's the blues. One of those purples ended up at the end of 3 blues. Now I can see that 1 purple, 1/2, is the same as 3 small out of the 6 total in the blue row. That's that visual that they need to see that. They need to get how that works together. Okay, and then in the end, for grade 3 and 4, we teach them how to switch the fraction to its equivalent fraction form. So if I multiplied the numerator by 3, I also multiply the denominator by 3. So they should know that already. And again, I put it here in case they haven't done a lot of work with the equivalent fractions. And the reason that this works, that was a question that somebody phoned me about the other day, and they said, why is it that we do that? Like, why is it we multiply top and bottom by 3, that it's okay to do that? Because you're multiplying the top by 3 and the bottom by 3. 3 over 3 is 1. If you multiply anything by 1, you've not changed the value of it. You changed the appearance of it, but you've not changed the value. So I could have multiplied it by 113 over 113. And yeah, they'd be bigger numbers, but it's still 1 that I'm multiplying the top and bottom. So you're not changing the value. That's why we call them equivalent fractions. They're not a different value. Okay. We also did this in grade 4, factors and multiples. So do they know their math facts? Could they list the factors of a number or the multiples of a number to help me find what's the lowest common number that they both have in common? So in this case, we were looking at 4 and 6. So where do 4 and 6 collide with a common number? Well, 4, 8, 12, 16. I'm just doing multiples of 4, multiples of 6. Well, I see right away that 12 is the very first number. It's not the only number. It's the very first number that they have in common. And that's that one we call lowest common denominator. Will it be wrong? Will I get the wrong answer if I choose 24? No, you will eventually end up with the right answer. You just need to do a little bit more reducing in the end so that we have it in lowest form. So it's just important for students to do some of that review work if they haven't already done that. Lowest common denominator will be the lowest number that they have in common. Any one of these will still give me the right answer, only I just have to do some reducing at the end. So if I have a question like this, often what students will do is they'll go 5/8 plus 1/4. If they don't understand what they're doing here in the division of the strip, they'll just take this and stick it in there, right? It fits, looks the same, so what's the big deal? So I get 6 of them. I get 6/8 of them. Okay, so if I had 5/8 add 1/4, I need to find some related fractions. What do the 8s have in common with quarters, right? So a quarter is the same as 2/8. If you use your strip, I can find out how they connect. And now I can add those two in, and I do get 7/8. How do I get that? I could find the common denominator. So this whole slide deck, I won't go through the whole thing, but this is in here all the way up to when we get into multiplication. So here's a bunch of questions that they can do. And I've even put on here, could they do a model? Can they solve the question, but can they also do it with a model? Could they draw a picture? Could they give them Cuisenaire rods? Could you give them pattern blocks? Give them whatever. Like, what could they do to draw this for you that they understand? Fraction strips. What would work for them so that they could model that this is in fact working and they understand how they got the answer that they did? Okay. All right, so let's just go through this really quickly to the end here. Let me just get down to it myself. Come on. Okay, I'm not going to do that. Okay, I'm not going to go through. Oh, yeah, there we are. So here we are. Why do I want to even do this? That's a common question that kids ask too. Why do I care about adding fractions together? Here's where adding fractions leads to into their math. So this is a precursor to many other things that they're going to do as they go through their math courses or other things that they do in life. So this is a place where we apply these. And I think that's always important for kids to see. This one, rationalizing denominators, isn't going to necessarily be something they understand until they get to grade 10, but it has a connection, right? Those are important pieces that we want them to be able to do. All right, so here's just 3 quick slides on multiplication. So this is that start of 6 and 7. What happens when I multiply a fraction by a whole number? And this comes back to when I said the importance of a unit fraction. So in your outline or in your curriculum document, it says that multiplying a fraction is really the same thing as taking a natural number and multiplying it by its unit fraction. So would a student, if you gave them any fraction, I gave you 4/9, would they know what the unit fraction was? What did they count by to get to 4/9? So they should know it's 1/9. So how did I get to 4/9? I multiplied the numerator by 4. I had 4 groups of 1/9, 4 hops of 1/9. Same thing with 4/10 plus 3/10. What is my unit fraction that would be used here if I was just doing the adding? Or how would I change this addition to a multiplication question? So 4/10 is the same as 4 times 1/10. 3 is the same as 3 times 1/10. So 3/10, 4/10 is really the same as saying 4 plus 3 is 7. I can break these together and make it 7 times 1/10. It's the same whole number. It's the same unit fraction. I'm just increasing the length of it in this case and getting more of it. So if I had 4/7 plus 3/10, this is where I might want to get out my colored fraction strips. Can they find 4/7 on the fraction strips? Can they find 3/10 on the fraction strips? Where do those two collide? It's going to be a big number for sure. But Do they understand how they would get that common denominator? So again, this is just to give you a sense of how we would integrate that N7 into the learning that the students have been doing with unit fractions. Okay, that's the important piece. Okay, so I'm going to leave that slide deck for a bit. So that's built in here. You've got access to it. Use it when you're ready for it. When we look at the algebra section, here's what we covered yesterday in grade 5. So it's in grade 5 that we identify constant term, coefficient term, variable, and inverse operation. This is where they learn all of those pieces. They learn to evaluate. They learn that they have parentheses in the order of operations. Up until then, it was multiplying, dividing, adding, subtracting for grade 4. Add the parentheses in for grade 5. Add in exponents for grade 6. All right, so that becomes kind of the move forward now. So when we're looking at this part of it, they're adding like terms together. So when I first teach the students how to get the term variable, that's one thing. But I also do it with pattern blocks, and I ask them to put things together. And why did you put those together? Well, they look the same. They were the same color. They were the same shape. That's a like shape, like color. That's like a like term. So they have to have a connection again about, don't just tell me what a like term is. Let me see what I would do as a like term first, and then it'll start to make a connection for them. So we actually start with pattern blocks. And I built that slide deck in here for you as well. So the algebraic properties, you have to remember in solving equations in grade 5, they do not know integers yet. So you can't do 2x minus 1 equals 4 because they don't understand.
Hello, Annie. Do I disturb you?
What a -1 is. Like that
Okay.
that's not going to work in their curriculum. So we have to make sure that we stick to adding in the question so that we can subtract as the inverse operation. In grade 6, we can do positive and negative numbers. That's fine. But they don't have that ability in grade 5. So you have to be very careful what kinds of equations we're going to show them and that they're actually going to solve. So Betty Morris did a great job of not only that the sheets that you see here, the algebra sheets, but she did a great job of putting together, looking at just quick summary as well of what we can do within the algebra components of this. So this gives you a sense of what it looks like, adding like terms, doing those types of things. So it's just a bit of a summary page that I think would be helpful. But when I start to look at this, once they've done the number side of it, and we already did those before Christmas, we worked on them in January. So if we go to 1.2, where students analyze expressions and solve algebraic equations, one of the things that they talk about is algebraic expressions follow the same rules as numbers. And so we need to be able to show that to students. And that's a toughie for them, because if they don't really get what that means, even with numbers, then we have to have a way of showing them how that could be. So I just grab Cuisenaire rods. If I want to show that A plus B is the same as B plus A, well, here is A, it's light green. Here's B, it's pink. When I take a light green and a pink together, I get a black rod. I don't care what the numbers are. If I flip it around and put the pink first and then the light green, I still end up with the same length of a black rod. So order did not matter. I ended up with the same rod. If I look at the next one where it talks about multiplication, A times B is the same as B times A. Well, I've got 5 groups of reds equals 1 orange. Those reds were 2, if we're talking about numbers. So 5 times 2 gave me 10. If I flip this around according to this, that would be a 2 and a 5. So 5s are yellow. 2 groups of 5 also gives me an orange. So it's just a way of visually showing a student where these come from. What do they mean? Not just they're there. Yeah, they work. We know they work, but they don't get why they work and where they came from. Let's do the last one where we talk about A plus B plus C. The order shouldn't matter in which I put them in. So if I went green, pink, red, what if I took the green and the pink and added them together first? That would give me a black. A black plus a red gives me a total of a long blue. So what if I change the order? What if I did these guys first? That would give me a dark green. A dark green plus a light green still gives me a blue. So it doesn't matter. And then the last one is the multiplication. You have three things you're multiplying together abstractly, and it shouldn't matter how I put them together. So here I've got the brackets in here. So 2 times 3 groups of 5 is really what this is. So here's 3 groups of 5, and I've got 2 rows of them versus 3 rows of 2 groups of 5. So here's my 2 groups of 5, 3 times over. I still end up with 6 yellow rods. So it's just for the students to see and understand what this means first. Putting the number parts in, but they need to understand how this came about, and that just shows them how those are going to get together. So from grade 5, again, if you've done this, great. If you haven't, you need to start here. We need to make sure that they have variables, coefficients, constants, expressions, equations. Here is a slide deck that I've included. It comes from grade 5, but it would be for grade 6 students as well, to understand how do I get the terminology of a variable out to a student. So I would use this to start with. I just give them a whole handful on their table and just say, can you organize them? So let's just say that's what you got on your table. When you organize them, you're probably putting together whatever looks the same. And why? Because it's an easy way for me to see it. I can see that the yellows go together, the reds, and so on. So what you've done is you put like shapes, like color together. And this is our precursor to talking about what are variables. They are things that look the same. They go together. So what does this have to do with algebra in grades 5 and 6? This is what they did in grades 1 and 2. They already did algebra. They've been doing it all along. The only difference is that now we're going to say, instead of just getting 11, what if I took one of those numbers away and put an open box in there? If I put an open box in, that's going to be like my variable. This is what they do up until grade 5. Grade 5, they change it to a variable. Now I can say, put something in the box. 3, you get 10. Put 5 in, you get 12. Put 100 in, you get 107. So whatever goes in the box is going to change what the answer is going to be. So the variable allows me to choose what values are going to go in. Just as an FYI for teachers, variables are always lowercase letters and they're always italicized. Okay, they're never uppercase. So when you look in a book, they should always have that format so that the students understand that from the letter X or a multiplication table. So we identify all of the terms that they need to know. We do practice with them. This is just a quick video or a quick slide deck that you could use with the students to get them going on it. But this gives you a sense of where we need to unpack before they get to grade 6. If they've got all this, we are flying. We are good to go. We can write equations. We can show them expressions. We can ask them to evaluate expressions because they already know what a variable is. They already know what an expression is. They know what a constant term is. Okay? They know what terms are. So in this case, we have to move them from, what do you see on the screen? What would you put together? And when I did this with students, they said, well, you put all the big M's together. And I said, well, how many M's would that be that you're putting together? And they just basically come up to the screen, start counting 1, 2, 3, 4, 5, 6. I said, so what do you have? Yes, 6 M's. Okay. How they said that's really important because that's how you want to write that expression. They added 6 M's together and they got 6M. They added X's together. They got 6 X's. How they write it is also how they say it is also how we're going to write it. And that's where we introduce the fact that you said you had 6 M's. How'd you get them? You added 6 M's together. You counted them. So a number in front of a variable, although this is an uppercase, just to make it obvious for them, the number in front means multiplied. There are 6 M's on the page. This takes away that 6x multiplication sign times M so that we don't confuse variables and operation signs. So this is how we introduce that notion of having a number in front of a variable means a product. And then they work from there. Okay, they get values. Okay, not sure what's going on here. This mouse of mine is not being cooperative. So as I keep moving through, now I can add like terms. That's grade 6. So can they find letters that look the same? Can they find numbers that look the same? What would go together? What wouldn't go together? And so now I can add them up and I can see what I would get as my final answer. So they should be able to identify an expression versus an equation. Remember that an equation has an equal sign, an expression does not, because I have unlimited number of answers that I can put in here. I don't have to have two terms. Even just a number is called a term. Even just a single letter is called a term. I can put them together and have two terms. I can put other things together and have three terms. For grade 6, we're suggesting that you stay to just X's, maybe Y's. Like, don't convolute the whole thing and just come up with a bazillion different variables. Let them start thinking about it so that when we come into equations, we'll stick to just those variables of X's to start with, just to make it a little bit easier for them. They can use M's and whatever if they're doing a simple expression. But if you're going to do equations, maybe just stick to some of the easier ones that have X's in them, because that would be more standard with what they would see. So if I look again at 5A 1.1, and this is also your 6, same thing. Can they write an expression? Can they put a number in for the variable? So here's an expression. I told you that X is 5. And as a standard notation, whenever we substitute something into an equation, we tend to put a bracket around it. That's just a standard way of people knowing that this was a substitution, and we put 5 in. This also helps them to see the order of operations of 2 times 5 goes first and then add 1. So that's the kind of thing that we would hope that they would be working from and have already done from grade 5 into grade 6. Okay, so let's move on to algebra tiles is what we'll come back to when we do the equations of solving with the integers, the opposite operations. I did give you, if you're already ready for them, here's a virtual one if you need them, but hands-on ones are way better for the kids to really get what that's going to look like. But over here, you also have an equivalence. In other words, when we talk about that balance scale, and we're going to do that when we solve equations, have they even worked with the notion of a balance scale yet? So this is another slide deck for you that you can access. And it will give you, this is a beautiful one from the UK, but it will give you an option to go in there and just have a look at how do I legitimize eventually when we get into equations, how do I legitimize that if I add 3 reds to the left, I have to add 3 reds to the right? Like, why am I doing that? And that comes from the algebra side of it. This is the numerical side. So if I took and added a 1 into this number without changing the total, then I should take a 1 away from this number. That's really what we're starting to get them to think about, is that balance scale. So you can't just jump from variables into solving equations. They have to have some sense of what it is that we're about to do. So I would not use all of these, but I would definitely go in and select a couple that we could show the students about the balance scale. And further down, they have balance scales in them so that you can see what those pictures look like. And then the last piece is that I want to finish in here, because we did talk about this, but I want to put the measurement pieces in here as well. And that is they're working on parallelograms. And the students need to understand what a parallelogram is first. And that's absolutely imperative. We don't just show them the definition of it. It would be great if you took them right into sort of this quick little snippet. Oh, no, that's not the one I want. We took them right into this very simple little demo of taking a rectangle, take a piece of paper, rectangle, and all they're going to do is take the familiar rectangle, which they've been drawing on paper already of length times width, and if I cut it and re-slice that side and just slide it over, it's still the same piece of paper. I'm just changing the look of the paper and changing it into another form of a parallelogram. And if it's the same amount of paper, even though it looks different, the area can't have changed. Although it looks different, it is the same piece of paper. So we want students to be able to understand that that's how the parallelogram, any parallelogram, a square, a rectangle is a parallelogram, but the ones that are on an angle like this, those are the ones we want them to understand how to find the area. And why is it base times height or length times width? Where did that come from? So the reverse of this, put it back and I build back another rectangle. Letting them do this with scrap pieces of paper that you have is a great way for them to learn and just see that. But that's a kind of a must do for them to understand that if a rectangle is length times width, Well, so is this guy. It's just that the width is actually what we sometimes call the height. And then from there, if I were to take a diagonal and put it in, I actually visibly see two triangles. So whatever formula I've used here, base times height, length times width, I have two triangles that come out of this. So the area of a triangle would be exactly half whatever this is. I don't really care what that number is. All I need to know is that it's 1/2 the length of the base times the height or the width, depending on what you're going to call it. So this is another way for them to get at. These two hyperlinks at the bottom give you an activity as well as Cuisenaire rods that could be used to model off the areas and perimeters. That's your second one. Talk about the rectangles and the areas. We can say that the area, show me a picture. We did this in grade 5, so I don't want to go back over doing the same thing, but if you didn't do it with them, the question was, can you find rectangles, draw them on a grid that have an area of 12? Well, there's a whole bunch they can draw here. There isn't just one. They can do long ones, they can do vertical ones, they can do this, but every one of these would have a different perimeter. So they need to understand how area and perimeter are and are not related, because that's going to be important. So this is just the slide from grade 5 that you've got built in here that you can use. So they would need some grid paper just to come up with this, and that they can figure out some general formulas for the area. Okay, last one, the review requests. So here are what people were asking for. They were looking for some additional examples of multiplying of decimal numbers. Yes, there's the traditional way that we can do it. We can talk about alternative ways. And then I've also included here some hyperlinks to places that you can go to see additional algorithms. And I think this came from the fact that people were asking about, well, it's just a standard algorithm. And I said, are you saying that singular or plural? And if you read your documents, there's an S at the end of this. There is no one standard algorithm. There's one that you probably grew up with and you think is the standard algorithm. That's a traditional approach, but it's not the only one that there exists. So what other ones are there and where would I find them? So I've given you some hyperlinks in here and some pages that you could go to. In addition, same thing for division. Okay, there isn't just one way to divide. It isn't just the number goes on top and where do I place it in the tenths column, hundredths column. That's one algorithm. There are several other algorithms, especially if kids don't know their math facts. Okay, and then the last one, we have 5 minutes. I'm going to get you to write these two numbers down on just a scratch piece of paper for those of you that are still with me. So people were saying, we don't have something for these big, big numbers. Like, what are we supposed to do with them and make it engaging? So I'm going to give you an abacus link, but let's write these two numbers down first. So 12,425 and add 6,276. Okay, and we're going to jump into a big one right off the bat. I'll throw this link into the chat box so that you've got it. If students have used Rec and Rex, then they're going to be familiar a little bit with this, but if they've never used it, then we'll put a few ground rules in place for them. Okay, it's in the chat box if you want to grab it. So what's the difference between an abacus and a Rec and Rec? First of all, color is one. Abacus has a true abacus when they first came out, usually has 10 rows of 10 different colors. The ones that you can buy now usually have 5 rows, and then it repeats again with the same color row combinations. But a true abacus would have 10 different colors. And the reason it has that is because each one of these rows has its own value. And I can change the value. I'm not fixed on one, and I'll show you where the templates are that I share with the students. But let's just start simple. Let's keep it simple. The bottom row is just going to be ones. The next row would be tens. The next row would be hundreds, thousands, 10,000s, 100,000s, and so on. Okay, we're not going to get crazy big today. But just so that we remember, the bottom one is starting at ones, tens, hundreds, thousands, 10,000s. When I do this with the students, I give them this virtual link because you can't buy these anymore, and nor would you buy them because it wouldn't be worth your money. but I do give them the template that shows what each row is, because that's not what I'm checking for. I'm checking to make sure they know how to do it. One of your outcomes is also you should be able to call out a number, and students should be able to show you what that number is. So we wrote it down right now, but I'm going to ask you to show me 12,425. So remember, ones, tens, hundreds, thousands, 10,000. So to get 12,000, I need a 10,000 bead pushed over, and I've moved them all over to the right because that's how they're used to seeing them. To get the 2,000s, I need 2 beads from the 2,000s. Now it says show me 425. So you're going to push over 400s and 20 and then 5. Okay, so I've shown you, and that's just to get them used to this, that's where I start. I just say, I'm going to call out a whole bunch of numbers. I want you to show them to me. And then we just walk around, or I have them look at their neighbor and say, do you both have the same beads pushed over to the left-hand side? That's a fast way to check, right? They don't, hands up, I'll come over and clarify who's got it right. And then we move them all back again. Now we're going to do an addition. So we're just going to fly through all that. Assume we did that already. They know how to do this. Now I want you to add to that 6,000. So go back, go remember from the bottom, 1, 10, 100,000. So find 6,000 starting in this light row. So you're going to push 6 of them over because each one is 1,000 in the thousands row. So grab your 6,000. And you had 200s. So I'm in the hundreds row, 200s, push them over. And 70. So I need 7 of these guys. And then it says push over 6. Now, we would never do this to start with. You wouldn't give them a regrouping question right off the bat. Well, I don't have 6 to push over. Well, I'm going to do this just like I would a reckon rec. If I was going to push 6 over, I would grab the 5, but I still need to push 1 over. But now I filled the whole row. So I'm going to put that one back and trade it for a 10. That's 10 ones, so I traded it for a 10. I was short pushing the 6th one over, so there's my 6th one. Oh, wow, I filled this whole row. I took all my 10s and moved them over. I'm allowed to trade a 10 for a 10. So now we can say to them, when you added them together, what answer did you get? So you got one, you got 8 of those. Okay, so I've got 18,000, 3 left over there, 700. There's no 10s, so 0 and a 1. And if you're not sure, add it up your old traditional way and see that you got 18,701. So students can use this as an addition. It's a great regrouping. It gets them to understand place value. If they don't know place value, they're going to struggle. So that's a good FYI for us. There's some misunderstandings in place value. But that means I can get into bigger numbers. I can give them 100,000 or whatever. Show me that. Show me 10 million. Show me a million, whatever. I can ask them for all kinds of numbers, and I can add small numbers to them. Initially, I wouldn't get them to regroup anything. I would just add, add, add. Now read off your number. I don't want paper and pencil. Read off your answer. What's your answer? What's your answer? What's your answer? And then we can get into some where they do some regrouping. And they can verify it on a piece of paper if that's what you want to do. So this is another way that I can do some of those values. So on the next slides here, you see that I've put the template on. This is what I photocopied for the kids and give them that. But you're also in grade 5, you go up to thousands. And then that's where it stays for grade 6 as well. So I can change the rules. I can change the bottom number is thousands, hundreds, tenths. This row becomes the decimal. And then I can go 1/10, hundreds. So now I can call out numbers that have to the thousandths, and I have a way of showing what those values would look like. So this is just one of those ways that you can use some of those big numbers and small numbers. Okay, that's lots of info. You've got the ARPDC site here. Those CPAR documents, we have about 11 of them sitting waiting for posting right now. So we just met with our person today and he's going to get on that. Yay, yes. And then we've got a number of the verbs. I just put them on here in case you haven't already downloaded what the verbs are. They've been defined. There's exemplars there for you. So just want to make sure that we're all using kind of the same language or the same end goal when we're talking about the verbs. Okay, so that takes us to the end of today. And that's got lots of stuff in there to unpack. I'll just stop recording in case there's any questions. There we go.